Before we start, let's look at goals of today's training. First, we will learn the role of EEV and fan. Second, we will learn the errors related with EEV. Lastly, we will learn the errors related with fan. An air conditioner is basically made up of major components such as a compressor, heat exchanger, fan, EEV and etc. Among them, we will learn how to troubleshoot the EEV and fan. First of all, do you know why an EEV is required for an air conditioner? An EEV is needed to remove pressure from the liquid refrigerant to allow expansion in order to make evaporation easier in an evaporator. In addition, it can control the flow of refrigerant much more sophisticatedly. Therefore, if a EEV has a problem, an air conditioner cannot provide normal cooling or heating. Next, the fan allows the air and refrigerant to exchange heat well by creating a airflow. And, it can absorb or release heat by fan. In other words, the fan of an outdoor unit releases heated air to outside and the fan of an indoor unit supplies cooled air to inside in cooling mode. Look at the product picture on the screen. Can you guess why water drop has formed on the surface of the product? It is usually caused by an EEV failure. As you already know, the EEV of the indoor unit that is stopped in cooling mode must be closed. But, if the EEV of the indoor unit is open a little bit due to the EEV failure even though the indoor unit is stopped in cooling mode, water drop may form on the product surface as shown. And, let's take a look at the next slide and see why water drop forms on the surface of the product. This shows the principle of how water drop forms on the product surface due to EEV leakage. So, we need to know why does EEV leakage happen? As you can see from the pictures on the screen, a EEV has an orifice which flows refrigerants. However, if the surface of orifice is damaged by foreign materials, refrigerant may get into the orifice through the gap and cause problems. Therefore, there should be no foreign material in a refrigerant pipe all the time. If refrigerant flows in stopped indoor unit due to EEV leak in cooling mode, the temperature of indoor unit's surface will decrease due to cold refrigerant. And eventually, dew is created by coming into contact with the warmer, moist air in the room. Let's see how we can see whether there is EEV leakage or not. First, you should turn on one indoor unit into cooling mode and the rest into fan mode. The EEV step of the indoor units operating in fan mode is 0 as shown. This means that there is no refrigerant flow in the indoor units. Then, wait for 10 minutes or more while checking the operation data through SNet Pro. After that, check the temperature of evaporator. The evaporator temperature of the indoor units operating in fan mode must be similar to room temperature. If the evaporator temperature is about 5 degrees Celsius or lower than the room temperature, it can be determined that the refrigerant is flowing due to EEV leakage. Then, you should replace the EEV. Now, let's look at errors related to the EEV. If the EEV is not properly opened or closed, the error may occur. When the EEV of indoor unit is not properly closed, the E703 error occurs first. Here, the condition where the error occurs is when the evaporator temperature of stopped indoor unit is less than 0 degrees Celsius. As mentioned earlier, the evaporator temperature should not be lower than 0 degrees Celsius because the refrigerant does not flow in the stopped indoor unit. If a primary error occurs, the indoor unit will restart automatically. Nevertheless, if the same problem occurs again, the E151 error occurs and immediately stops the operation of indoor unit. In this case, you should check the evaporator temperature sensor status and find the cause by checking the resistance of the EVE coil. And if there is no problem, you should replace the EEV body. Of course, an error may take place for the opposite situation. When the EEV of indoor unit is not properly opened, the E702 error occurs first. If the room temperature and the evaporator temperature of indoor unit are similar despite the indoor unit operation, this error occurs. and the indoor unit will restart automatically, similar to the previous error. And then, if the same problem occurs again, the E152 error occurs and immediately stops the operation of indoor unit. If an error related to an EEV occurs as mentioned earlier, you should first check the wiring status of the EEV connector and coil. And then, you need to check whether the coil resistance of each terminal is normal or not. By the way, if the coil resistance is normal, you should replace the EEV body. As shown on the screen, a EEV is largely divided into head and body. And, if the EEV head is broken or a motor's pushing rod is misaligned with body's shaft, it can cause a problem. Therefore, for those cases, an EEV should be replaced. Next is about fan errors. If the fan does not operate properly, error codes named E446 or E346 occur. What's the cause for those errors? It may occur due to connection problem of fan motor or defective fan motor or PBA. So, what should we do to solve this problem? Let's find out how to solve this kind of problem together. This shows how to inspect fan PBA. It's very simple. What you only need is a multimeter to check whether the PBA is working or not. The resistance of the measurement points shown in the table should be measured to ensure that the value is in the normal range. If the resistance value is out of range, you should replace PBA of the fan. This slide shows how to inspect a fan motor. First of all, there are three types in motors, such as AC motor, BLDC motor with internal control PBA, and BLDC motor with external control PBA. Depending on the type of motor, different cable is connected. For this reason, inspecting a fan motor is different a little by each type. First, let's see about an AC fan motor. AC motor has two different connectors. One is for power and another is for hall sensor. When it comes to the connector for power, you can check whether it is normal by measuring resistance between the two cables. At this time, don't forget to power off and disconnect the connector before inspection. On the other hand, to check the hall sensor, it's required to supply power and connect the connector. And then, you should check the DC voltage between the two cables by manually rotating the fan motor. At this time, if the voltage is stable, the motor needs replacement. Then, let's see how to check a AC fan motor in the following footage. The following is about a BLDC fan motor with internal control PBA. You should turn off the power before inspection, and then disconnect the connector of the fan motor. It has only one connector for power supply. And you can check whether it is normal by measuring resistance between the two cables. See the screen for the measurement points and normal range. In addition, you can also find whether the motor has a defect or not by manually rotating it. Next is about a BLDC fan motor with external control PBA. Actually, compared to the AC motor, troubleshooting is the same. The differences come from the measurement points between cables and normal range. See this slide for the measurement points and normal range. We saw the troubleshooting method for a fan motor so far. From now on, we will see how to solve problems for a PBA of indoor unit. First of all, let's take a look at a fan PBA with AC motor. You should turn off the power before inspection, and then disconnect the connector from the fan motor. At this time, the indoor unit should not be running. And the DC voltage should be measured, and if the voltage is similar to the input voltage, it is determined to be normal. In other words, if the input voltage to the indoor unit is 220 volt, the normal value is around 220 voltage. The following is about a fan PBA of indoor unit with BLDC fan motor. There are 3 measurement points where DC voltage should be checked. One of those 3 points needs power supply to the indoor unit, and DC voltage should be measured when the indoor unit is not running. And the rest should be measured while the indoor unit is operating in fan mode. See the slide for the measurement points and normal range. As we have seen so far, you can easily check the fan motor and PBA if you have only a multimeter.